This is question 4 from the first CSAT sample paper. In this question we're simply asked to find the last digit of this sum, the sum from 1 to 1337 of n factorial to the 4. So if you want to have a go at this question yourself, pause the video now. Okay, so first things first, we definitely can't calculate this. Why did they pick this number? Apart from making a little joke, it's just to pick a number so big that we can't actually calculate these terms. These are going to get very big very quickly. And sometimes when you have a sum, you can start writing out terms and they simplify somehow. It doesn't look like that's going to happen. We don't have many identities for n factorial, definitely not for n factorial to the 4. And usually when they simplify, there's some way of making a difference between terms, which we can't do here. So how do we approach this? Well, we're asked for the last digit, and one of the main things to recognise here is that if you have the last digit of a sum of terms, to find that all you need to do is add the last digits of all the terms. So for instance, if I take one of these terms, it's going to have digits and then tens and then hundreds and thousands. If I add all the tens and hundreds of thousands of the different terms, I'm just getting tens and hundreds of thousands again. I'm not getting last digits. So last digit comes from the last digits of each of these terms added together. So maybe now we can just start writing out terms and look at the last digits and see if anything happens there. So if I start writing out terms, okay, 1 factorial is 1, and then we've got 2, 6, 24, 120. And now I stop here. So once we get to here and definitely to here, it's actually difficult to start working out these powers of 4. You could do it if you had to. But we haven't actually written out the last digits yet, so I haven't seen the pattern in the last digits yet. But what I have seen is here, this is a multiple of 10. And every subsequent term is also going to be a multiple of 10 because you get to do the next factorial just by multiplying by some numbers. So once this has got a factor of 10, the next term is going to have a factor of 10 and so on. And that means every term from here onwards ends in 0, and therefore it's not going to make any contribution to the last digit of the sum, because we're just adding things that end in 0. So the last digit is going to be the last digit of this. So we just need to find the last digit of the sum of these 4 terms, which is much simpler. So you could actually calculate this, but it would take a bit of time, especially to calculate this. So we'll try and find a slightly quicker way of doing it. How are we going to do that? Well, let's just think about what the last digit of each of these has to be, because we only care about last digits. So 1 to the 4 is obviously just 1, so it ends in 1. 2 to the 4 is 16, ends in 6. And now 6 to the 4, we could work it out, but the main thing to note is if something ends in 6 and you multiply by 6, you get something else that ends in 6. Like if I have 36 and I multiply by 6 again, I've got 6 times 30, that's going to end in 0, plus 6 times 6, and that's going to end in 6. So whenever I have a power of 6, it ends in 6. And we can actually do a similar thing here. Just think about the last digit. If I think of to the power 4 as squaring and then squaring again. If I square this, because the last digit here is 4, I'm going to get the same last digit as 4 squared, which is 16. So I'm going to get 6 when I square, as the last digit when I square 24. And then if I square that again, because it ends in 6, I'm doing, the last digit comes from 6 times 6, and that ends in 6. So I can see this is also going to end in 6. And then when I add these 4 terms together, it's just going to end in the last digit of this. So if I add these 3 together, well, it comes to 19, but the main point is that ends in 9. Because that means that the last digit of the whole sum also has to be 9. So our answer to this question is 9.